Finally, in this video, I'm going to continue. So we are in specific activity. As I'm saying in the previous video, when you want to calculate specific activity, the formula is activity all over protein. So, and if you see this table, let's just take one of them. Let's say ammonium sulfate fractionation. The specific activity is 0.6. So how will you get that? So according to this formula is activity over protein. So just look for the activity of that particular process, which is 24, and divide that value by the protein. So 24 over 4,000 will give you 0.46. In similar manner, 1,440 divided by 500 will give you 2.88. You know, I mentioned this the other time. So it should not be 2.0. Because of course, the only thing that can give us 2 if divided by 500 should be 1,000. So since this figure is not 1,000, this is 1,440. That means 2 should not be the answer. So if you do this 1,440, which is the activity, divided by protein, will give you your specific activity, which is 2.88. Do you understand? So let's move to the next one, yield. How do you calculate the yield? If I say yield, this table, how do you calculate it? The formula is I superscript A all over S superscript A times 100. What do I mean by I superscript A? Instantaneous activity. What do I mean by instantaneous activity? Activity at that point. That means if you want to calculate the yield of crude enzymes, the activity at that point is 3,000. So this is the instantaneous activity. That's I subscript A. Sorry, superscript A. Superscript. Then if you now want to calculate for the SA is what? Starting activity. So this one is still the starting activity of itself. So do you get it now? Because this is the first person we are seeing. That means 3,000 will be the IA, 3,000 will also be the SA. It will be instantaneous activity and also be starting activity, because this is where we are starting from. So when I do that, it's going to be I superscript A divided by S superscript A. That will be 3,000 over 3,000 times 100. So by the time you do that, it's going to be something like this: 3,000 over 3,000 times 100. 3,000 over 3,000 will give you what? 1. Then 1 times 100 will give you what? 100%. That is why the yield at this point is 100%. Because at this point, the activity of crude enzymes is crude. So it's serving as both I superscript A and serving as S superscript A. So this formula works. If you can apply it, there's no flaw. You're going to get your answer. I raised power A means instantaneous activity. Activity you are talking about. That specific activity you are interested in. Then starting activity is S superscript A. So let's take another one. The yield of 80%. How do they get it? Just said instantaneous activity. The activity at that point. The activity of ammonium sulfate fractionation is 2,400. Then you will divide it by your starting activity. So that means for this, 24 is the instantaneous activity, while 3,000 is the starting activity. So 3,000 will always be a control for all of them, because 3,000 is the first activity, that's the starting activity. So the how we solve it, you are going to say 24, do you get it, divided by 3,000 multiplied by 100, where 24 is your instantaneous activity, while your 3,000 is your starting activity. Because we are talking about ammonium sulfate fractionation, the instantaneous activity is 24, which is 24, while the starting activity is the beginning activity, which is 3,000. When you do that, you are going to get 80%. You can pause the video and press your calculator in the same manner. But if you do this, as I told you, I said instantaneous activity divided by the former. That means if you said 1,440, instantaneous activity divided by starting activity. So to get the yield of this ion exchange chromatography, you have to set 1,450, which is the IA in this scenario, instantaneous activity divided by the SA. The reason why this one is having 2 is because I said at the first instance, 3,000 is both IA and SA for itself. But in this case, the other ones are the IA, instantaneous activity, while the beginning activity is called the starting activity. So it's going to be 1,440 divided by 3,000. So when you do that, you are going to get this value. You are going to get 48%. But after you divide IA by SA, you have to multiply by 100. That means for this one, it's going to be 1,440 divided by 3,000 times 100. If you do this, you are going to get 48%. 48%. So that's how they get all this answer. Do you get it? So in this place too, I've already corrected it. So now, why do we get 10 here as specific activity? You know, I've already said that specific activity is activity over protein. So just go to the activity of this, which is 500 over protein. Of course, if you say 500 over 50, it should not be 40. So that means 40 is wrong. That means the answer is supposed to be what? 10. And in this case, if you say 1440 over 500, 1440 is not 1000. That will give us 2. That means 2.0 is wrong. It's supposed to be 2.88. Do you get it? This formula works. Just make sure you are familiar with it. And finally, I'm going to be discussing about the sixth term, which is the purification factor. Now, the formula I put here is ISA all over SSA. ISA means instantaneous specific activity, unlike this one that is instantaneous activity. This one is not instantaneous specific activity. And SSA means starting specific activity. So to get your purification factor, you will divide your instantaneous specific activity by the starting specific activity. That means when you are talking about purification factor, you are going to streamline your attention only in the specific activity table, chamber. So just check this specific activity. So to get the specific activity of this one, that means this 0.2, since is the first one, the crude enzymes, how did they get 0.2? How did they get 1.0? Because we are looking for purification factor. So yeah, I said that you have to focus on specific activity chamber. Now, it's because at this point, this 0.2 is serving as ISA and at the same time serving as SSA. Because this 0.2 is our instantaneous specific activity. That is what we are interested in. And also, it is the beginning or starting specific activity. So it's going to be dividing itself. It's going to now be 0.2 divided by 0.2. So definitely you are going to get 1. Did you get it now? But for this one, I will not solve it fractionation. 0.6 is actually the instantaneous specific activity, ISA. So this 0.6 now, we're now going to divide the SSA according to this formula. ISA divided by SSA. So the SSA is the starting specific activity. So the starting specific activity is what? 0.2. So by the time you say 0.6 divided by 0.2, you are going to get 3.0. And for this one, I've already corrected this. This is 2.88. So 2.88 is the instantaneous specific activity here. So when you divide it by the starting specific activity, you are going to get this answer. You are going to get 10, not the purification factor. Okay, you are going to get the answer. It should be 2.88 divided by 0.2. You can pause the video and actually get the answer. So I think you are going to get, is as if you are saying, so you are going to get 14.5. If you do that, 2.88 divided by the starting activity, you are going to get, so don't mind my correction, I think they are right here. So 2.88 divided by 0.2, you are going to get 14.5. And in similar manner, how will you use this one to get your purification factor? 8.0 here is the ISA, instantaneous velocity at this point, gel filtration. So you are now going to say 8 divided by 0.2, you are definitely going to get 40. And in this case, since we now have 10, so it's supposed to be 10 divided by 0.2. And it will be 10 multiplied by 2 all over 10, multiplied by 10 divided by 2. So this is supposed to be 50. Yes, this is supposed to be 50 because you are going to say 10 divided by 0.2. This is instantaneous specific activity, while this beginning is the starting specific activity. Starting. That's why it's starting. It's starting the reaction. So 0.2 is going to be 10 divided by 0.2. And when you do that, you're going to be having 10 divided by 2 over 10. That's the changing decimal to fraction. So if you want to change this into multiplication, you are going to say 10 times 10 divided by 2. 10 times 10 is what? 100. 100 over 2 is what? 50. That means the answer here is going to be what? 50. They are wrong here. So this is supposed to be the answer. Now, if they now want to ask you that which of the process is the best process for the purification of these enzymes, this is the best process. Because the process that have the highest purification factor is the best process for purifying our desired enzymes. I hope you are blessed by this my video. Once again, I'm your favorite tutor, Phillips Olamide Oladile, the director of Education. Please try and watch, comment, share, and subscribe to my YouTube channel to encourage me and to have more of these amazing videos. I wish you success in your exam on Thursday. God bless you. Thank you. Goodbye.